Good morning, Year 10. In this video, we're going to be looking at parabolas, but we're going to be looking at how they shift to the left and the right. So in our last lesson, we talked about how they get wider and narrower by changing the number in front of the x. We talked about how they flip to the other side if we have a positive or a negative, whether it looks like a smiley face or a sad face, and how they shift up and down depending on what number we add or subtract at the end. But today we're going to be talking about how they shift from the left and the right. So I'm going to point out some things, but I'll just read this statement here. There's two sentences. The graph of a parabola, y equals a outside of x minus r all squared, has shifted to the right, r units. When y equals a outside of x plus r all squared, the graph has shifted r units to the left. Okay, so basically there's two things to note. This number here tells us if it's how far it's moved, and if it's positive or negative tells us the direction. Now it's the opposite to what you'd think. You'd normally think, oh, negative, that would go to the left because that's how the number line works. But it's actually the opposite. So this is shifting to the right, this is shifting to the left. Okay. We've got one example for this today, so it's a bit shorter video than last lesson because all we need to talk about is just moving to the left or right and just put it into practice. The other lesson was a bit more in depth because we're talking about parabolas and lots of stuff going on with them. So our example says to graph each parabola, clearly showing the vertex and y-intercept. Now I've got three parabolas to do, and I'm going to do them one at a time. But I'm most likely will put them all on the same graph just so we can look at them and compare them. Okay, so the first thing I'm going to do is do my axes. I'm going to do it as big as I can fit. Okay, now that may not turn out to be much, but we'll just see. I know a lot of you like to halve your pages, and this might be an opportunity where I probably go across the two halves for this, just so you can really look at the differences here. So I'll label my axes, and I'm going to, I think I'm just going to do by going up by ones every single notch. So I don't have to make as many notches. I'm only going to label every second one. Okay, and we're going up. So we have 2, 4, 6, we go up to 8, -2, -4, -6, -8, -10. I didn't go to -12 because I did more in the positive. And then we'll do the same going down, -2, -4, -6, -8. Now, the reason why I do it all in one graph is because that process of labeling out the axes every single time is time consuming. So if we can speed up the process a little bit, then we should. Now I need to do my axes, so my table of values. So I'm going to just write them over here, and I'm going to do them one at a time, and then I will get rid of them just because of space. Okay, so I'm going to do -3, -2, -1, 0, 1, 2, 3. All right. Okay, and now I'm going to do this one first. Oh, excuse me. This one first, and I'm going to use the same process, but every time I see an X, I'm going to put brackets. Now, I know that's probably going to look like bracket overkill, but it's just to make sure that we get the right answer every time. So what happens when it's -3? Okay, you have 3, -3 minus 1. Just make sure I've got all my brackets in my calculator. I get 16 in there. Then I change it to -2. I get 9, and then so on. So I'll pop it all into the calculator, and we'll see what happens. Now, I talked about last lesson about the importance of not assuming that it repeats at any given point. We're going to see what happens if there's anything happening here. So you'll see it did have a point of symmetry, but the point of symmetry was not here like it was last lesson. Now it's actually here. That's the point of symmetry. So that's important to take a note of, that you can't just assume that it will have a point of symmetry at 0. You have to actually see what will happen. So I'm going to plot these on my graph. So -3 goes up 16, too big for my graph. -2 goes to 9, that's pretty close. So I'm going to pop it there. -1 is 4. 0 is 1. 1 is 0. 2 is 1. And 3 is 4. Now, even though we didn't put it on axes, you can see that it's going to look symmetrical. So I can actually do the next one, which would be 4. So for this one, I can bring it all the way up to there and make a symmetrical parabola. So I'll connect those up with a curved line, do arrows at the end, and I'll label it. In this case, I'm just going to do a 1 because otherwise it'll get really messy. But you can see what it looks like there. Now, comparing it to what it would normally look like, you can see that the parabola has been shifted to the right by 1 space. So you can see, because this was -1, we've shifted it one unit to the right, which means that every dot has actually been shifted once to the right. Okay, so the normal curve would look something like this. And now it's all been moved to the right. Every single spot has gone to the right by 1. And that's all that changes when we do it like this. Now it looks a bit more confusing because there's brackets, but that's why. All right, now we'll look at B. Now B is very similar, except we've got a negative in front here, and now it's a 2 instead. A 2 instead. But you'll see it's a +2. So what we know before we even draw it is that it's going to be sad, and it's going to shift 2 spaces to the left. Okay, that's what that tells us, and that's what that tells us. So we're going to do our axes again, table of values again. I get those words mixed up for some reason. Table of values and axes. I guess it kind of looks similar. Either that, I'm just crazy. Crazy sounds about right. Okay. You'll notice I get bunched up, but that's just because I'm trying to fit it all in here. And once again, in the calculator, it's going to look like this. Minus bracket, 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 +2 squared. And I'll chuck in the -3 first, and so on and so forth. Okay. So -3 + 2. All squared. It gives me -1 as the first number there. I'm going to put in -2 in the brackets, I get 0. When I put in -1 in the brackets, I get -1. So we found our point of symmetry. And when we put in 0, we get -4. When we put in 1, we get -9. 2 is going to be -16, and I'm going to run out of space. 3 is -25. Now I'll plot these points on the graph. When x is -3, y is -1, so that's our first point. -2 is 0. -1 is -1. 0 is -4. 1 is -9, and that's all I'll be able to fit. But so we don't have to draw the table of values again, almost at axes again, I will replicate these dots here, put them on the other side, because that's where the point of symmetry is. Okay, so it looks like that. Then I'll draw it, and do the arrows, and that was our second drawing. Okay, so I'm going to label that 2. Okay, so like we thought, it was negative, so that means it's a sad face. Okay, sad face. And it's been shifted twice to the left because it was plus 2 when we think about it in the opposite way. Great, we'll do one more, which is C, and then there's one other thing we need to do, which is show the vertex and the y-intercept. I'll talk about that after. So this is our third one, and I'm just going to rub out all of this. And we'll do it again. This is the last one for today as well, so that's good, not so much as yesterday. So I'm going to do 2 bracket plus 1 all squared. So what we know about this, before we even do it, is 2 means it's going to be narrower, it's positive, so that means it's happy, and it's been shifted once to the left because it's a positive 1. Okay, so I'm going to put in values. So the first one I'm going to do is -3. So type in the calculator with all those brackets. I know it looks crazy, but it gives you the answer, so may as well do it. We get 8. When it's -2, we get 2. When it's -1, we get 0. When it's 0, we get 2. So there's our point of symmetry there. 1 is 8. 2 is going to be 18. And 3 is 32. Okay, so let's put them on the graph. I'm just going to change to a different colour. I'll do green, I haven't done green yet. Now, -3 is +8. So, you know what, we're not going to use this last bit here with 32 and 2 with 18. That's just way too big, just so I've got some room. So -3 and 8. -2 and 2. By the way, you'll wonder why was I able to just rub that out? The table of values isn't there to, so we can fully complete it. It's there so we can see what we can and can't do. So that's why I was able to do that. Then we got -1 and 0, 0 and 2, and 1 and 8. Okay, so you'll see a very narrow parabola, which has been shifted one space to the left. So exactly what we were expecting. So that is our third parabola. Okay, so I'm going to clear up some space by getting rid of the table of values. And now let's talk about the vertex and y-intercept. So this is the last thing to talk about. Now the y-intercept is probably the easiest thing to talk about, so we'll talk about that first. The y-intercept is where does it hit the y-axis. So it's the same as with a straight line. So where does it hit this line? So for the first parabola, it hits here, and that's at 0, 1. So I'm going to write underneath. So for 1, we've got the y-intercept is at point 0, 1. Okay, and then I'm going to write vertex underneath because we need to talk about that as well. But before I confuse anything, let's just do the y-intercept for each of them. So that's 1. We'll do it again for 2. We'll do it again for 3. Okay, so the y-intercept for 2 is, you'll see here, it hits the y-axis here, so that's going to be 0, -4. You'll see that for all y-intercepts, they always have x value of 0. For 3, we have 0, 2. Okay, so that's the last one for the y-intercepts, which is here. Now, the vertex. The vertex is where the parabola turns. That's the point of symmetry, okay? So that is the vertex. So we just have to say what that point is. So in this case, it's going to be 1, 0. Okay, so we've got 1, 0 for the blue one, which is 1. For 2, which is the black one, we've got -2, 0. And the vertex for 3 is going to be -1, 0. Okay, so that's basically That's basically it. So when you graph a parabola, do the table of values. It doesn't matter what it looks like. All that matters is that it has a square in there. The highest power is 2. Put in the table of values, see what it looks like. But remember, you can have a general idea of what's going to happen when you can see the sign, when you can see what number's in front. And now you know whether it's going to shift to the left or the right. So this would be to the left because it's positive, and this one to the right because it's negative, the opposite of what we think. All right, hopefully you can get some practice in there for the from the textbook, so make sure you check Google Classroom for that, and I'll check your work.